Right. Okay.
So good evening, class. Good evening, learners, wherever you are from home. I am Mr. Mushira Mwangi, and I'm going to take you through a physics lesson in electromagnetic spectrum. I believe most of us have been able to cover the previous topics, including dim lenses, circular motion, floating and sinking, and most of the schools before the corona thing, we had gone up to electromagnetic spectrum. Actually, I was almost starting, so we're going to repeat it so that the learners can be able to, we can be able to go together, all of us. Now, electromagnetic spectrum is a transverse wave that is usually produced from as a result of oscillating magnetic and electric fields. Now, from our Form 2 waves, I want us to just go back to Form 2 so that we define wave, and then we look at a few properties of wave before coming to electromagnetic spectrum. Because we need that knowledge so that we can understand more about all these waves in electromagnetic spectrum. So, from our Form 2 definition of wave, we said wave is a transmission of energy through space, or propagation of energy. Propagation of energy through space. Propagation of energy through space. When you look at the term propagation, it's transfer or transmission, then energy. Remember, physics is the study of energy, of matter in relation to energy, and that's why waves possess energy. Now, these waves are transported or propagated through space. The energy is propagated through space, or we can say it's a transmission of disturbance. Transmission of disturbance. And this is more clearly visible when you have a pool of water and maybe you put a stone on it. There are waves that are produced. Those waves move from the epicenter where you've dropped the stone, and then they move towards the edge of the pool. You can see the transmission of that disturbance. And that's what we are saying, the definition of waves is propagation of energy through space or transmission of disturbance. Now, students, you can remember there are two types of waves. One of them is mechanical wave. So we have the types of waves. We have mechanical waves. And the other one, I'm pretty sure you know, it is electromagnetic waves. Electromagnetic waves. Now, our focus mostly will be on electromagnetic waves. By definition, mechanical waves are the waves that require material media for transmission. Material media for transmission, while electromagnetic waves do not require material media for transmission. And here is where our focus is when we talk about electromagnetic spectrum. We'll be looking at these waves. Now, the term spectrum means a band. A band that is, there is a whole band, as in there is a whole range of waves ranging from, we're going to list them in a few. They range from the waves with very low energy to the waves with very high energy, waves with very large wavelength to the waves with very small wavelength. Now, where else will be, or before we come to listing the waves, let's look at how this electromagnetic spectrum, how these electromagnetic waves are produced. Now, as we have said, in a moment please, as we have said, electromagnetic waves are produced by interacting or oscillating electric fields and magnetic fields. Now, you remember in our Form 2 again, where we have electric current or the magnetic effect on electric current. whenever a current is moving through a conductor, there is an associated magnetic field. More so when also current is when there is a magnetic field, there is also an associated electric field. So when they interact and they oscillate perpendicular to each other, so say this is magnetic field or electric field E oscillating perpendicularly with a magnetic field labeled B, they produce an oscillating transverse electromagnetic wave. And this is how electromagnetic waves are produced, and this would be the direction of the wave. You can see they are meeting at an angle. So in our Cartesian plane, we'll have a y-axis, an x-axis. Then the electromagnetic wave will be produced in our third or our z axis, and this is the wave that we are most concerned with. This wave is the one that we're calling electromagnetic wave. Electromagnetic wave. Now, there are several examples of electromagnetic waves, and we're going to look at them. We list all of them in the order of how they follow each other in the electromagnetic spectrum. So in this case, we'll start with the radio waves. Then we have the microwaves. From the microwaves, we have the infrared waves or radiations. Then we have the visible light. You have the UV light. You have the UV light there. Then from here we have the X-rays. Then the gamma rays or the Y rays. Now, in a few minutes, I'm going to show you the electromagnetic spectrum on a video or a clip that shows the production of electromagnetic spectrum and the bar that we're talking about. So we're going to pause for a moment. We show you the video. Thank you. Say post.